Ladies and gentlemen, my name's Paul, and I'm going to be joined by one and only, how else can I introduce him, Neil Trevett. Neil, would you like to introduce yourself?
Hey everyone, hey Paul. Yes, I'm Neil Trevett, so I'm VP of Developer Ecosystems at Nvidia, but I'm also the elected president of the Khronos group, and we're talking a lot about Vulkan here today.
Yes, because we have some very exciting announcements on Vulkan, but we're going to make them wait for that. So let's start out with some of the simpler things first, and then we can kind of get to the more complex topics. Because I want to lay some of the groundwork for some of the future questions. So one of the big announcements that you guys recently had was that Valve Lunar G, the Brenwell workshop, were working alongside Khronos to allow portability of Vulkan to run on essentially Apple devices. And there was a quote from Valve that we've been running substantial production loads through Vulkan tools on Mac, including Dota 2, and I believe it was about 50% improvement in speed. So would you like to kind of tell us how all of that came to be, what the reception has been in the industry, and how you feel that this is going to help the ecosystem in gaming, as well as obviously improving the popularity of Vulkan?
Yes, absolutely. So this was a release we did just over a week ago, and Vulkan, as you know, has designed to be an open standard, portable to any system who wants to adopt it. And indeed, Vulkan is available on almost every system, but for commercial reasons rather than technical reasons, Vulkan is not natively available on Apple systems, macOS or iOS, and of course that's Apple's decision. But for developers, it creates an issue, because if you want to have a multi-platform application and you suddenly have to support 2 or 3 rendering backends, that can significantly increase your porting and support costs. So the number one question we get from developers is, when is Vulkan going to be available on Apple platforms? And in response to that, we created what we've called an ongoing project called the Vulkan Portability Initiative, which is simply the Vulkan working group at Khronos, working to create a set of open-sourced tools to let you easily port a Vulkan application using standard Vulkan over to platforms that don't support native Vulkan drivers. So in Apple's case, what the tools do is they take Vulkan program, including the Vulkan shaders, which will be Spir-V shaders, and cross-translate the shaders, and you have a runtime library that maps the API calls. So you can, with very little effort, bring your Vulkan apps and run them on both iOS or Mac OS. And in addition, the announcement last week, Lunar G, which is the company that creates most of the Vulkan SDKs out there, have ported their Vulkan SDK to actually run on the Mac. So you can actually use the Mac as a Vulkan development platform with all of the tooling layers, and that feeds down into the runtime library, which is Molten VK. It's a runtime library that's been available as a product for over a year, but Valve has been kind of driving bringing Vulkan onto Mac, and so Valve and a company that creates Molten VK called Brenwell Workshop have now put this into open source. So it's totally free to use and available in open source. And as you mentioned, Valve have actually used Molten VK and the Mac version of the SDK to actually run the real live production version of Dota 2 on Mac, and they're getting now about 50% more performance, typically up to 50% more performance than running the same application using the OpenGL backend.
Can I just pause you there, because one of the things I noticed with that performance, I mean, it was, for example, on a MacBook Pro, and I think the GPU is like a GT650M, and I saw, I mean, this is just one example, but it was like 36 to 54 FPS, and to me that's very impressive. Given, I mean, obviously if it was like a very high-end GPU, you can kind of understand it, but to me, what's really impressive about that is it's very mainstream hardware. It's old hardware. I mean, some of these systems are like 2013, 14, and you're still seeing this level of speed up.
Yes, yes, and you know, obviously Valve are doing quite a lot of measurements, but the performance measurements that they included for the public release, you're right, it includes quite a broad range of hardware, because they're trying to check that you always get a speed up they don't want to put out, because they're going to be putting this out as a free update for Dota 2 users. And they want to make sure that everyone enjoys a speed up. Now, the speed up will kind of depend on where the balance between your CPU and GPU is on a particular system. Because Vulkan typically helps when your CPU is more of the bottleneck, because it's more CPU efficient. But yes, and the good news is all the systems that they've have released figures for so far are going between 30 to 50% faster. So yeah, it's good news for everyone.
Do you think that, I guess this is a joint part question, but I'm guessing that from developers, never mind the public, because obviously the public are going to jump to whatever ecosystem is well supported, but I guess where I'm going with this is, it's kind of strange because Microsoft, they made this decision to essentially mean DirectX 12 was locked down for Windows 10. I mean, obviously you've got Xbox, but for the wider sense of things, it's really a Windows 10 ecosystem. And now you've got Vulkan, which is just opening up to so much, and we'll definitely move on to more when we're talking about Vulkan 1.1. But it's like, I guess it's kind of strange because you're seeing the situation now with Apple being so big. It must be very exciting for developers to actually have this one API that essentially they can pretty much target anything. They can go with iOS, they can go with obviously Mac OS, they can go to Windows, they can go to Linux, they can Android. It's pretty much up to them.
Yes, I mean, and that is has always been the central core mission of Vulkan, not only to enable state-of-the-art explicit access to GPUs. I mean, that's what developers have been wanting, and to do it in a portable way. So wherever you want to run your 3D application, you can use a single backend API. Now, Vulkan from the get-go was designed to be portable and open, and this set of tools is just the last piece that lets us bring it onto systems that have a good underlying API. I mean, both Metal and DX12, they're both good APIs. It's the portability, though, of course, that gets broken if you have to use those platform-specific APIs. So now with the Vulkan portability,
Vulkan now has more games that's supporting it as well.
It does. Yeah, it's kind of surprising. It's a mix of mobile games and desktop games, but there are some AAA games that now only use Vulkan, and of course it lets us bring titles onto Linux as well as the other platforms that we've mentioned, because Vulkan is available on many of the Linux platforms, and that brings the state-of-the-art GPU access onto Linux using the same rendering backends as on a PC. These games can now be way more easily ported onto platforms like Linux. And the Vulkan portability initiative, I mean, this Mac set of tools is kind of the first deliverable from the initiative, but now we're looking to enable other runtime libraries, and running over DX12 is definitely on our roadmap, because there are things like UWP, things like Xbox, that probably are never going to have native Vulkan drivers, and we can enable Vulkan apps on those platforms. And it'll
work, for example, with the Xbox One.
So the way these runtime libraries work, it's basically it's open source, so you can essentially bring this library into your application, and in the end, it will emit DX12. It's just like another DX12 app, but internally inside your app, you're making Vulkan calls. You're just using this runtime library to do the efficient mapping from your Vulkan calls into DX12. But in terms of the Xbox, it doesn't know, and it doesn't have to know any of that.
So essentially, it's almost like So essentially, it's almost like an intermediary. The game is talking to Vulkan, and Vulkan is essentially communicating to DX12, but it's kind of, for lack of a better word, tricking it by thinking it's part of the app.
That's right. I mean, depends on the platform you're on. There are various ways of linking in the library. You can, on the Mac OS, you can do it as a statically linked library or a dynamically linked library. Or, as I say, it's open source. You can bring the source into your app, and there's be one linked app. It really depends on the platform we're aiming for and what the developer wants to do.
So I'm assuming that would also, in theory, work with the PS4 as well. Eventually, in theory, you could do that.
In theory,
with the port.
Yeah. And the big goal of the portability initiative is to grow the set of open source tools. Someone would need to do the mapping from Vulkan calls into the underlying set of native API calls that are available. But yes, they can build on all of the open source that we've already put out there. It would be possible for really anyone to port to anything that has a good underlying API.
How, let's say for example with the Mac OS, or like Metal or DX12, would there be a performance hit? If so, would it be just a couple of percent than if you were to code natively?
We're trying to have very minimal performance hit because we realize that people aren't going to use this if it's slow. And so there's been quite a lot of thought, careful thought, sometimes ingenious thought gone into how do you map Vulkan calls into the Metal calls, for example, for the Apple tools that have just been released. We don't want to lead developers over a performance cliff where, yes, okay, you support that call in Vulkan, but it's going to take, multiple megabyte copies behind the scenes and lots of shuttling, and your performance is going to be poor. What we've done is found a way to kind of one-to-one map Vulkan calls into Metal calls. Now, there are a few things that is about like 5 functions that we can't map efficiently. So we actually identify those, and we say don't use those because we haven't figured out a way yet to map it across. But the good news is, it is just 5 functions out of the whole Vulkan API, and everything that's there and working in the Vulkan VK library, is intended to be high performance. The way to look at it, I think, is any well-structured Vulkan app is going to be tuned so the CPU is not a bottleneck. Vulkan lets you batch up large command buffers which are submitted down into the GPU very efficiently. Just a few CPU cycles creates a lot of work on the GPU, and so adding a few more cycles to do one or two more function calls in the mapping library, typically won't make any difference to a well-formed application. So yeah, ideally, there'll be no difference at all in the level of performance that you get.
Awesome. So I accidentally let the cat out of the bag. So Vulkan is now moving to version 1.1. So
yes.
Congratulations to that. Before we get into the technical side of things, let's go over, I guess, from the perspective of developers and gamers, how things have changed. So as of March, as I mentioned, you've now got 34 games which are working on Vulkan. That's actually 7 higher than DirectX 12.
Right.
And Vulkan, as you mentioned, is very popular for Linux at the moment. You've got Rise of the Tomb Raider, Mad Max, and other titles, which are a lot of it's actually been ported by the folks over at Feather Interactive with memory serves. So I guess what I'm going to ask you is very similar to my last interview with you, and that is, what do you think about progress overall? What do you think you would have done differently in the benefit of hindsight? And what do you think are proudest? What would you say you're proudest of for the API since last we spoke?
So overall, I think things are going really well. You mentioned a few of the highlights. So if you go to the Wikipedia page that tracks Vulkan and DX12 titles.
Not that you're constantly keeping an eye on that or anything.
Well, it's. I think the landscape. DX12 is an awesome API. and Metal is an awesome API as well. I mean, and as well as Vulkan being awesome. I mean, they share lots of, as we talked before, they share lots of design principles. Metal is not quite so hardcore explicit as the other two, but they're all forward-looking. And if I was a developer that was only developing for Windows, or if I was a developer that was only developing for Apple, I would use the native API. I mean, it's on the platform. It's supported well by that platform. But very many developers do want to ship across multiple platforms, and it's those developers that we think Vulkan adds tremendous value to. Not only do you get state-of-the-art GPU access, you don't have to keep rewriting your backend to support the different APIs. And I think the momentum that we're seeing for Vulkan reflects that basic fact. It's not to talk down Apple with Metal and Microsoft DX12. They're doing what's right for their platform, and they should do that. But there's a place in this universe for people that want to have portable applications, and that's our role. And of course, and don't forget, Vulkan is also the native 3D API on Android, which is the largest platform in the universe. So there is a platform sponsor behind Vulkan as well. So I think in terms of our proudest moments, I think you look at titles like Wolfenstein 2, Doom VFR, that are now shipping on PC. They're obviously AAA titles, and they have felt confident enough in the Vulkan ecosystem that they only have a Vulkan backend. They don't have a DX12 backend. So I think that really kind of proves that Vulkan is here and is supporting these AAA titles. I think the Vulkan portability initiative is cool. The fact that we now can reach out to Mac is awesome, and iOS, and the fact that the good work that Feral does, bringing these titles easily from PC onto Linux, is a good illustration of the fact that the dream of portability lives.
It's real, damn it.
Yeah. And that Wikipedia link that we do, I mean, it's a real link. I mean, it is tracking the number of publicly announced games for Vulkan and DX12. As you say, Vulkan is 34, DX12 is 27. It's not apples to apples, because the Vulkan link does include some mobile apps, but it's a slightly different mix. But the large perception out there, the reason we include that link, a little bit tongue-in-cheek, I guess, but that there is a large perception out there that there are literally hundreds of DX12 apps and only one or two Vulkan apps. But it's really not. It's way more equal than that.
I think, honestly, and this is my personal perspective, and just judging from what I'm hearing in the industry, from whispers, from talking to gamers, and pretty much covering this stuff. But I do think that Microsoft somewhat leveraged the position that they've got Windows 10, and we're using DX12 to try and push the upgrade, if you will, because they were betting the fact that Windows 10 was free. Unfortunately, developers just didn't want to bank on it at the time, so a lot of developers stuck with DX11. I do think that did really, really hurt their uptake. And obviously, there was also the whole fact of, it is a new API, it does take a long time to code in, the native backend of the engines as well, for example, Unreal Engine. But I do feel that Microsoft probably somewhat hurt themselves with the adoption of DX12, in the short term anyway. In the long term, obviously, it'll be fine. In the short term, maybe.
Yeah, I mean, I think Microsoft is doing a good job. We don't have to. I know many people like to kind of make it into a GPU API war, but really that's not really where we're coming from. The platform should absolutely be free to do what they consider to be best for their platform. That's what they should do. But it's not the only way to access GPUs. There's a place in this world for cross-platform access as well, and we're just trying to do the best job we can in that. And we're living alongside the platforms that are doing the best job that they can too. I think to turn your question though around, so what is our weakest point and where do we need to focus to make sure Vulkan continues to be successful. And that is the strength of the overall ecosystem, because that is somewhere where Apple and Microsoft excel. They have the resources, they can invest in the tools, the compilers for their APIs, and that is the potential weak spot for a cross-platform API. You don't get that same level of investment in the tools, the compilers aren't quite as robust, etc. And we're, you've seen our 1.1 launch materials. That's why we're putting so much emphasis on the fact this 1.1 launch is way more than just a new spec. It's an ecosystem step forward for the whole industry, where yes, we have the 1.1 spec and there's some cool new functionality there, but really, almost more importantly, we are really pumping up our investments in tools, in compilers, in conformance testing. The launch includes not just the specification, but new tools. The compilers continue to be invested in. Everything's in open source, which is one way to enable the industry to invest in the tools. We have the conformance tests, the Doctors program, and we even have GPU vendors that are shipping conformant Vulkan 1.1 drivers on the day of the specification launch. So you'll hear a lot about us talking about ecosystem, and that's why we need to compete head-to-head with the level of investment from the other APIs.
So I guess that does bring us to the next logical question. So there's a couple of things. So first of all, with 1.1, the core spec. So you've added new features and also a plethora of popular extensions. So yes. For example, you've added multi-GPU, you've added multi-view, and I guess those were just. I think what I'm saying is that this is, going back to what you said, a great example of why Vulkan is proving popular, because it is an open ecosystem. So when something does come along and developers request it, it's very easy to kind of add this stuff, right?
Yes, that's right. So, and you're right. So Vulkan 1.1, it's obviously we're going to have regular updates to the Vulkan specification. It's an evolving, living specification, and we want to meet requirements from developers as they evolve over time. Our normal way of bringing new functionality into a new core spec is to test out the functionality first with extensions. See which ones work, which ones developers are not interested in. Potentially get some learning experience from shipping an extension before that same functionality gets baked into core. And as you mentioned, there's a whole bunch of 1.0 extensions that now have proven their worth in the industry, and they are now coming into core. And those things, as you mentioned, things like key functionality for advanced VR rendering, multiple GPU, a better shader language flexibility, so you can do more compute type stuff, cross-process and cross-API sharing, which again, VR systems use for advanced compositing, things like that. All things that have proven their worth are now in core. And there are a couple things that are so important have gone straight into core, because we are pretty sure that they're going to be needed. So things like protected content, so we can play back DRM protected videos. The GPU can actually be blocked from copying and reading where the area that video is being played from. And probably the most important thing is subgroup functionality.
I'm going to bring to that. A lot of folks seem very excited about that. I mean, AMD, for example, said that it's almost console-like level of optimization, and then Codeplay Software, who Continental, they say it's very important with latency-sensitive applications.
Yes.
So I guess what exactly is a subgroup operation, and then you can kind of explain why it's so important.
Right. So going back to GPU 101, you have a bunch of things happening in parallel, and you have a bunch of processors that contain compute units, and they're all operating in parallel. But with the latest GPUs, you can have multiple tasks running on one GPU compute unit, and the naive way of running those is that they each have blinkers on. They never talk to each other, and they're just running their own program on their own data. And that certainly is useful for many applications. But the more interesting applications, they want these parallel tasks running on the GPU to be able to communicate to each other. And again, the naive way of doing that is to going out into shared memory. You can, any GPU can access shared memory at any time, and you read and write between the threads. But that takes a lot of synchronization overhead, and going out to memory will suck your performance, because you want to keep things on chip, on processor as far as possible. So subgroups are basically a way for these parallel tasks running on a compute unit inside a GPU to very efficiently swap data and compare notes on data and come up with very rapid, efficient ways of cooperating together between these multiple threads. So you can have one thread, for example, that's broadcasting to all the other threads. You can shuffle data between the threads. You can do arithmetic operations, like you can add up all of the data from all the threads and come up with a total. You can find the minimum or maximum values that they're running across the threads. And these are the type of operations that are used by many of the cutting-edge apps like inferencing, vision processing. It's very enabling to be able to do these kinds of multi-thread operations at almost zero performance overhead.
Because that's kind of the thing as well, because a lot of folks, I guess this isn't really a question, it's more of an observation, but Vulkan and the ecosystem that Khronos is building, it's not just for gaming. I mean, and we'll go into more some of the vision processing and other stuff in a minute, but it's like you've got car manufacturers and folks who perhaps do even basic compute functionality, 3D rendering. I mean, you've got some studios who are never ever going to use gaming. They're building 3D engines for example, medical research, or for example, for cinematography and rendering. So it's like Vulkan is really extensible in the fact that it, as you said, it's an ecosystem which is part of so much of a wider group.
That's right. The right way to we had OpenGL, and that's called like a 3D graphics API. Actually, but the right for Vulkan, I think the right description, it's not a 3D graphics API. It's a GPU API. You can use Vulkan for doing anything you want on a GPU, and as you say, that for many years now it's included compute, and that whole the compute on GPU is growing in importance as well as the rendering.
Yeah, exactly. I mean, there's a reason that GPUs. I mean, this is a slight aside, but there was an absolutely bizarre. It's not bizarre when you think about it, but to a lot of people, it's kind of bizarre that there was a news article that popped up that was doing the rounds that with the whole mining shortage, GPUs becoming so prohibitively expensive or so difficult to purchase, the search of actual extraterrestrial life and searching for planets and so on is actually being hit because these huge radio telescopes require an enormous amount of GPU power to be able to process the information that's actually coming back. And it's like, you don't think about that stuff. The average person would not think about that. But obviously there needs to be a tool set in place, and the actual languages there in place to be able to do this stuff. And it's really awesome.
Yes. No, it's having this amount of compute, available to, many different types of applications is changing the world. It's actually pretty awesome to be part of that.
I can imagine. So also you released a new specification as well, and this goes hand in hand with Vulkan 1.1, correct?
That's right. So to remind folks, Spir-V is the name of the specification. Spir stands for Standard Portable Intermediate Representation, which is a bit of a mouthful. And
I always say Spir, it's really like, sorry.
Yeah, no, it's Spir. Spir is the
Okay.
and the Spir-V. The V is for Vulkan because it started out as an OpenCL intermediate representation, but then we added Vulkan, and so it's Spir-V. But it's actually very simple in concept. It's the basic programming language that Vulkan understands. So all the shaders, whether you're doing rendering or compute, like we just discussed, it doesn't matter. Any of the shader stages, they understand Spir-V, and you can have different high-level languages that are being compiled down into Spir-V. So we're way more agile than OpenGL ever was, which just took in GLSL, which is the OpenGL shading language. We can certainly bring in GLSL, of course, but we can also now bring in HLSL, which is the DX12 shading language, which is super popular again amongst many developers who are out there. We can even now bring in the OpenCLC shading language, which has more compute capability, and with the right compiler front end, you can bring it down into Spir-V that can be ingested by either Vulkan or OpenCL or OpenGL. So as you add new functionality, and subgroups are a perfect example of this. Subgroups now, we can do a lot more complex operations between these parallel threads. You need to be able to express that in the shading language. So this is a new capability that needs to be added to Spir-V, so that the front-end compilers who are understanding what the developer is talking about in terms of subgroup operations needs a way to express that in the Spir-V program so it can actually get executed on the GPU. So along with Vulkan 1.1, we have Spir-V 1.3, which includes new functionality like being able to express these subgroup operations, and the two go hand in hand.
And also, you've made major strides to the Vulkan layers as well, right? You've got both the Vulkan layer factory, device simulation layer, and finally a system layer. So could you quickly go over what those three capabilities would be for developers?
Yeah. So and this is something that from Luna G, which is a company that adds a lot of value to the Vulkan ecosystem. With Vulkan, we're very everything's open source, so anyone can create Vulkan SDKs. They can take the open source tools and create an SDK. Even if it's for their own system, they can be very focused, or they can produce SDKs for a variety of platforms. But Luna G are the company that's out there doing good work in open source, and it is the SDK that's used by the vast majority of folks out there. And again, to remind your listeners out there, the Vulkan has no debug or error checking built into the driver. So during development time, we use the Vulkan loader to bring in tools layers. So you can have a debug layer, or you can check that you're calling the right function calls for your target platform. You have a variety of different tools layers that plug into your driver stack during development time, and then when you deploy your application, you just take those layers out, so there's no overhead. And Luna G are the guys that have been putting a lot of awesome expertise into creating these layers, and they've been hard at work. As you mentioned a few things, so they have now the Vulkan layer factory, which is kind of like templates for new layers, and a lot of the detailed work is common between the layers, so they've really kind of templated that. So if you want to create a new layer for doing your own kind of debugging, you can pick up the VLF, the Vulkan layer factory, and get off to a flying start. They've been doing a lot of work since SIGGRAPH actually was where we first mentioned these simulation layers, which is if you're using a PC, for example, developing an Android app, some of the mobile phones may not have all of the optional Vulkan functionality that may be available on a PC desktop. So now you can plug in a layer called a simulation layer and say, okay, I'm using Android version 7 point something with a particular target device, and it will flag to you if you use functionality that's not going to be there on the target device. It saves you debugging hassle. And the latest one is the assistant layer, which is going deeper and deeper into not just finding errors, which is hard errors, which we've had layers for that for a while, but it's really guiding people to best practices. So doing things in a way that's going to probably cost you performance, things that are not going to be very cross-portable across different platforms. The assistant layer will be kind of looking over your shoulder saying, if you're going to do that, there's a better way of doing this. Really just trying to guide developers who are interested and want to install the layer into best practices.
But as your own slides point out, the fact of the matter is, because Vulkan is a little happy, it's essentially the driver, if you will. Vulkan is almost saying to the developer, look, we trust that you know what you're doing, but in return for that trust, it's not like you're being punished. You're holding the hand through the development process, so that when that game actually runs, they get the best performance possible, so they don't have this baggage kind of like weighing them down.
That's right. That's right. So it's best of both worlds.
Exactly. Which is obviously it's critical as well for low power devices, like for example mobile phones, because then you've got less stuff running on the processor.
Yep. Exactly.
Speaking of, I guess kind of in the same vein, I remember one of the big things we were discussing last time is glTF 2.0.
Yes.
And back then, of course, you added in things like physically based lighting, improved and more robust animation systems.
Yeah.
But one thing I actually noticed, and I wanted to throw it in here because obviously glTF is a pretty big deal in of itself. But there was a really cool thing actually that I saw. I think it's called the Draco extension.
Draco.
Yeah. So this is geometry compression. There's claims of up to 12 times compression, which is absolutely profound. I mean, so this compresses vertex position, texture coordinates, color information, and a lot more besides. So
yes,
this means that obviously downloads can be faster, 3D graphics can load quicker, and this is very important as well for reducing bandwidth. So can you just kind of give us an overview of A, how that works, and B, what type of differences it's going to make for A, developers, and B, end users?
Yes, absolutely. So glTF is one of my favorites.
I can kind of tell. I noticed pretty much everything authored by glTF is like you.
No. That's not true. That is absolutely no.
I'm teasing, but
I try to help promote it. But no, there's a lot of people putting lots of effort.
I was teasing.
Yeah, but no, but it's good because it's filling in a basic gap. I mean, everyone, and to remind people, the glTF it's a file format, and for 3D assets, scenes and models that includes animations, lighting, texture, and of course there are dozens of 3D file formats. So when we first started glTF, the people said, why? We have dozens already, but actually it did fill this gap in the ecosystem. There was no file format that was easy to load and included the rich graphics of textures, animations, and now physically based rendering. There was just nothing out there. Everyone was creating their own thing. And so it's gained a tremendous amount of industry momentum. You might have just noticed last week, Facebook, for example, now lets you drag and drop any glTF model into your Facebook feed. So
really?
Facebook, yeah. So it's really becoming quite pervasive. But I think you're right to kind of highlight. It was a couple of weeks ago, 2 or 3 weeks ago. Google for some time have had awesome geometry compression technology called Draco, and it's all in open source. And they've been putting a lot of work into taking the geometry characteristics that you mentioned and using the a priori knowledge that this is geometry. They can compress it down by a factor 10 or more. And this is a kind of a marriage made in heaven because they have awesome technology, but it needs to be associated with models. And then glTF is there now getting tremendous industry momentum. And we want to make the downloadable models smaller and faster to transmit.
Has joined the meeting.
So the what we've done now is a Draco extension to glTF. So any glTF file can be a lot smaller, and all of the encode and decode functionality is out there in open source. So any engine, any browser can easily decode these files, and again, everyone benefits.
Awesome. It's going to be very interesting over the next couple of years how we start seeing that, especially with connections becoming faster and mobile devices becoming faster as well naturally.
Yeah.
I mean, we're going to start to see some really awesome in-browser games and, well, just general usage scenarios, right?
Yep, exactly. I think it's literally going to be everywhere. And the strength of glTF, we've kept it simple, so everyone can use it. Everyone benefits because everyone benefits if we can easily share models, share tools, share viewers, the browsers, can all understand the same thing.